The Global Aerospace Summit's NextGen initiative is dedicated to inspiring and capacity building of the new emerging talent, as well as promoting the importance of STEM education. Professor Ojha, Director of the UK National Space Academy and Member of Council of STFC, is someone who has dedicated his career to the same cause and believes in the inspirational power of science. In this address, Professor Ojha shares his perspective on how science can transform young generations and their perceptions of the world.
Assalamu alaikum. Hello, everybody. My name is Ojha. I'm calling from the United Kingdom, and it is my deep honor to be able to share with you today some of my personal perspectives on how space has inspired not just myself, but countless others around the world. And more importantly, how we can use this inspirational power to draw in and to train our next generation of space scientists, aerospace scientists, engineers, and all of the other personnel that we need to ensure that the global aerospace sector fulfills its potential. When we are thinking about space, we need to remember that the internationally accepted boundary of space is much closer than many of us realize. Space is only 100 kilometers away. Space is closer to where I am now in the city of Leicester than the distance to London. But the problem, of course, is that that 100 kilometers is straight up. And if I want to get to that boundary of space, I must battle against the force of gravity, a force that has dominated the way that life has evolved on Earth for billions of years. And if I want to stay in the space environment, I must deal with an environment from a radiation, from a thermal, and from a pressure point of view that is far more challenging than anything we experience here on the surface of the Earth. So, if we were to take a simulated journey from the heart of the United Arab Emirates to the boundary of space, this is the sort of view we will see. Now, this is a simulation based on Google Earth. And as we ascend to that 100 kilometers altitude and look northwards towards Iran, we can see here a horizon distance that is more than 1,000 kilometers away. This was a simulation, but this is the real view. This is time-lapse photography taken from on board the International Space Station. So this is the type of view that UAE astronaut Hazza al-Mansouri was enjoying during his increment on the ISS. And what I love about this type of imagery is not only do we have an unparalleled clarity in our view of the cosmos, but looking downwards, we have a living geography lesson. We can see the interplay of the solar wind with Earth's magnetic field funneled into the upper atmosphere to create the beautiful aurorae, the northern and southern lights. It's a living physics lesson. We see the patterns of lightning storms, but crucially, in terms of human development, we can see the pattern of city lights, and we can see the growth of wealth and prosperity reflected on a time span of only decades when we look at those patterns of city lights. So it is little surprise that this overview effect we have, the idea of being an astronaut and enjoying this ultimate view, is such a trope, such a draw for so many people to come into our sector and into the wider aerospace sector. So human spaceflight is probably the most visible part of the space adventure, but really, when it comes to space science, to my mind, my personal categorization is that space science has three parts. There's astronomy, looking out there. There's exploration, going out there. But then, of course, there is the part that many people overlook. Satellite applications. The satellites looking back here to planet Earth. Those satellites providing the services that are essential to our way of life. And I would like to share with you some personal perspectives from all three areas of how these have changed fundamentally our way of life and our understanding of the universe during my lifetime. And I would like to begin with the theme of astronomy. People across the world, from every culture, have looked to the night sky for inspiration, for meaning, for understanding, for as long as we have been human beings. But I wanted to pick specifically the Hubble Space Telescope. Hubble was launched in 1990. This year is the 30th anniversary. And of course, as a NASA European Space Agency mission with the involvement of scientists from many other countries, Hubble has rewritten many of our fundamental textbooks and our understanding of physical sciences and astronomy, as I say, in my lifetime. Hubble was launched in 1990 and there was a problem with its optics. They were corrected on the image you can see on the left from shuttle mission STS-61 in 1993. And since then, Hubble has returned amazing science and amazing images. And I want to share with you some of my almost favorite images. Firstly, a view of M16, the Eagle Nebula. This is a region where new stars are being born, a huge dust cloud. Our solar system was born out of a cloud of dust and gas, very similar to this. It is worth remembering that our entire solar system in this image would have the scale of about 1 pixel. This dust cloud is thousands of light years away in our galaxy. And so Hubble has shown us the birth of stars like our sun. But Hubble has also shown us the death of stars. This is an object that has the name NGC 6543, but I prefer the Cat's Eye Nebula. And this is what happens at the end of a star, very similar to our sun, at the end of its life, as it puffs out its outer layers to form a planetary nebula. So in 5 billion years, this will be the most likely future outcome at the end of our sun's life, at the end of our solar system's existence. And in this other image where the colors have been enhanced slightly, we can see far more detail that is incredibly beautiful, but of course, incredibly rich in science also. And Hubble has shown us galaxies in unprecedented detail. This is M51, the Whirlpool Galaxy, a collection of 100,000 million stars plus, many of them like our sun. And this is so far away that the light has taken 29 million years to reach us. We are seeing it now as it was nearly halfway back to the extinction event that wiped out the dinosaurs, the KT boundary event 66 million years ago. Now, again, we have seen images of these objects from Earth previously, in some cases for centuries, but never with this sort of clarity. Now, these are some of my favorite Hubble images, but for my very favorite image, I would like you to, perhaps with me, undertake what we call a thought experiment, or perhaps a real experiment. I would like you, on your thumbnail, to imagine that you are drawing a square 1 millimeter by 1 millimeter, as I've shown on the slide. And when we look at this square, I just want you to imagine then that you are holding it 1 meter from your eye and looking at the sky. And the reason I'm doing that is because for the image I'm going to show you, Hubble looked at a patch of sky which seemed to be empty. And the angular size of that patch of sky was 1/20th of a degree of arc. So we are talking about the size of this 1 millimeter by 1 millimeter square held here. Now, this was a patch of sky that seemed to be empty. So Hubble looked at it not just once, but again and again, collecting more and more photons and starting to image objects which could not be seen initially. And over a total of 840 orbits of the Earth, looking at this patch of sky in the constellation of Fornax, Hubble took one of the most amazing images we've ever seen in science. It's called the Ultra Deep Field image, and here it is. Now, the more polite amongst you may be thinking, well, this looks very nice, but this does not have the beauty, the majesty, the grandeur of those previous images. Why is he getting so excited about this image? Well, what we see in the Hubble Ultra Deep Field image, what emerged in that tiny patch of sky were 10,000 dots. But each of these dots was not a star like each of these dots is a galaxy. Each of these dots is a galaxy containing hundreds of billions of stars. And so in this tiny scrap of sky, when Hubble saw 10,000 galaxies, each with hundreds of billions of stars, Hubble has repeated this in different directions, and we know that the distribution is fairly uniform. And what this means is that with a simple mathematical calculation, which I won't go into now, but it's surface areas of spheres, we can use this image and high school maths to make an estimate of the number of stars in the universe. And when we do this from this Hubble image, this is the number that we get. For the mathematicians, you are looking for a number of about 1.2 times 10 to the 22, 1.2 times 10 to the 23. What is special about this number? Well, we can also show using high school physics that this is more than the number of grains of sand on all the beaches of planet Earth. Hubble has not only transformed our understanding of the universe, but it has also brought home the scale of our home in the universe in a very human, in a very emotive way. This is how astronomy has changed, and now I want to talk about exploration. I first fell in love with astronomy when I was 5 years old, and in 1973, this was the best sort of telescopic view we had of the planet Saturn. Now, since then, in my lifetime, we have undertaken robotic voyages of exploration that have not only changed our understanding of the planetary bodies and satellites in our solar system, they have transformed the moons of the giant planets like Saturn and Jupiter, Uranus and Neptune from points of light that we could barely make out in the most powerful telescope into worlds that we have mapped, that we have studied with spectroscopic techniques, and which are continuing to amaze us. This is a composition of 30,000 still images taken on one orbital pass of the Cassini spacecraft. Again, a NASA European Space Agency mission with the involvement of scientists from around the world. Now, again, looking at these images of the gas giant Saturn and its enormous ring system, these are in a clarity that we never could have imagined when I was a child. So we have beauty here, but we also have dynamic behavior that even now we don't fully understand. As we sweep over the enormous ring system, we're now going to sweep past the moon Enceladus, which is a topic that I will come to a little bit later. And here you can see, as we're approaching Enceladus, the camera angle will swoop around almost as if it's out of a science fiction film. But this is not special effects. These are real images that were taken by Cassini on one of its multiple orbits passed during its Saturn mission. And here we go, swooping past Enceladus. So in making these discoveries, robotic exploration has meant that we have discovered worlds of fire. This is Io, Jupiter's innermost Galilean moon, slightly smaller than or about the same size as our own moon, but the most volcanic object in the solar system. We've discovered worlds of ice. I mentioned Enceladus. When I was a child, this was regarded as a fairly boring moon. You know, it's much smaller than the Earth. You can see here, it's barely the size of the United Kingdom, even smaller. But all of that changed in 2005 because Cassini, on one of its flypasts, produced these astonishing images of salt water geysers erupting from a crust that covers the surface of Enceladus. On subsequent flypasts, using infrared imaging and using spectroscopic analysis, we have discovered organic compounds here. We now know that Enceladus has a saltwater ocean below its crust, a saltwater ocean that is warm and that has organic compounds inside, the potential ingredients for life. So within the space of my lifetime, this has changed from being a boring world to one of the most likely places for us to look for life elsewhere in the solar system. And of course, in terms of human exploration, it is now more than 50 years since arguably the greatest voyages of exploration that the human race has ever undergone. And I'm talking about the Apollo missions to the moon. In the 4 magical years between 1968 and 1972, the 24 human beings who went to the moon and the 12 who walked on its surface became the only members of the human race to have explored directly an alien world. We see a beautiful image here from the Apollo 15 mission in 1971, And on the right-hand side, you can see images from the Lunar Reconnaissance Orbiter satellite orbiting the moon, made much more recently. And what is astonishing to me is that the footprints and the tire tracks that you see at the Apollo landing sites, they of course have maintained their integrity because there is no active weathering on the moon. They will maintain their integrity for millions of years. Humanity has truly made its mark on the cosmos. And much more recently, of course, we've had the International Space Station program, humanity's orbiting science laboratory in space. This is a marvel of engineering and orbital construction. The first modules were launched in 1998, and for 20 years now, we've had a continuous human presence off Earth with scientists, with doctors, with test pilots and the other astronauts, utilizing the space station for up to 6 months, or in a couple of cases, nearly a year at a time, and contributing to human understanding, not only of science and engineering, but also of the fundamental skills we will need if we are to explore further out in the solar system with missions to Mars. This image here is again one of my favorites. It's from the STS-131 mission, docking with the International Space Station. And what I love about this image is it shows how much the human spaceflight experience has changed since I was a child, because we now see representation of astronauts, not just from the Soviet Union or Russia and the United States, but from space agencies around the world. We see astronauts of all ethnicities. We see astronauts with backgrounds as diverse as having been test pilots or engineers, or in the case of one of the astronauts in this picture, Dottie Metcalf-Lindenberger. Until 2004, she was a high school science teacher and was then selected by NASA and qualified as a mission specialist astronaut. And of course, in the United Arab Emirates, the mission of UAE astronaut Hazza al-Mansouri not only inspired the nation, but also showed the ambitions and the potential of how a young nation like the United Arab Emirates can contribute to space science in all of its manifestations, not just human spaceflight. And of course, satellite applications. Now, this is the economic driver for so much of our space activity. We take it for granted, but we absolutely rely on these services that we are getting from space. Global telecommunications, global navigation satellite systems. Without the atomic clock timestamps from the GPS constellations orbiting Earth, our global financial transaction system would grind to a halt. Almost instantaneous global telecommunications have been made possible because of the telecommunications satellites. And what is interesting is when you look at the figures on the graph on the right-hand side, these are the global revenues of the global space sector directly, not in millions of US dollars per year, but in billions of US dollars per year. And last year, that figure was probably in excess of 400 billion US dollars global revenue and turnover. Space pays for itself many, many times over. It's a fundamental part of our way of life, and it is part of our critical national infrastructure. But moving away from these straightforward satellite applications, what about our understanding of what we are doing to our environment? We're all familiar with data sets from meteorological satellites, but this particular one, again, is incredibly beautiful because it is combining visual spectrum data sets with computer fluid dynamics modeling, and we're seeing the hurricane season of 2007 centered on the Atlantic Ocean. And what we can see here is a combination of the visual imagery of dust coming off the Sahara, also with a simulation of sea salt levels in the atmosphere, and of course smoke from the burning of crops in North America. And the reason why this is so interesting is that this is very beautiful, but it's rich in science, it's rich in data. The sea salt and dust form what we call nucleation centers. And when we look at Storm Ophelia, which developed far to the east of where it normally goes, it actually took all of that Saharan dust, and from the United Kingdom perspective, in October 2017, you could see from the animation, that was the day that the skies of the United Kingdom turned orange. We can also detect trace quantities of gases in our atmosphere that have been injected due to human activity and which are having a crucial effect. What you're seeing here is the annual hole that still forms over Antarctica because of the breakdown of the ozone layer. This was something that was going on and we had no idea because of humanity's use of CFCs, chlorofluorocarbons. It was a discovery that was only made by scientists combining space data with Earth-based data. When we have an armada of satellites monitoring the planet's health in real time, we can start to see the effects of human activity on the planet. In this particular data set, we are seeing sea surface temperature measured from space. And as we look on the left-hand side, we can see the years from 1993 to 2004. On the right-hand side, we can see the sea surface temperature. The reason why this is so important is with the enormous amount of energy stored in water, it is that heat release that is driving so much of our planet's weather systems. As we move towards Antarctica, we can see how the continent almost doubles in size every Antarctic winter during June and July with the formation of sea ice. And as we change our perspective to a more equatorial perspective, we can see that powerhouse of ocean currents, how they are driving our weather systems, and have no doubt about it, climate change is real. Having data sets from space means that we can measure in real time, and we are seeing some of the challenges for our next generation to have to try to solve. And finally, I wanted to share this slide because these are the most important factors globally when it comes to food production. Food production is our most pressing issue. How do we feel the global population of 9 billion, which will be the figure in 2050? It was 3.5 billion when I was born in 1968. Well, we can do it, but we need to understand not only the effect of air temperature and rainfall, but the ratio of precipitation to evaporation, how moist the soil is, where the runoff water is, what are the global wind speeds. And these are variables that in many cases we can only measure in real time globally from space. Space is absolutely crucial for what we are doing in the future. And I'm delighted to see the progress of space activity here in the United Arab Emirates, because again, so much attention was focused on the astronaut program. We've had the most recent astronaut selection for the UAE that has just finished. But the establishment of the UAE Space Agency many, many years ago, of the Mohammed bin Rashid Space Center, and of course, missions like the Al Amal mission to Mars, Dubai Sat-1, the Sharjah Center for Astronomy and Space Sciences, and other academic institutions, the UAE, as an ambitious young nation, is correctly investing across space science and, crucially, is investing in inspiring and supporting the skills development of its next generation of scientists and engineers. I've been privileged enough to be working with many undergraduate students over several years from the UAE, and I'd like to share you the perspectives of one of them, Lolo Al-Kindi, who I have been working with my team with for several years, and I'm delighted to see that her story is reflected in many other personal stories here in the United Arab Emirates.
Hi, I'm Lolo Al-Kindi. I am one of the UAE Space Agency student ambassadors. I graduated with a physics degree from Sorbonne University, and now I'm working in New York University as a research assistant. I'm working with our CubeSat team on developing and launching RADSat to space. Being an astronaut is the greatest of my dreams. That is because I am a very curious person. I just want to know how the universe runs. But until I'm an astronaut, I'm going to learn every part there is about the space sector. I'm going to continue researching and meeting with people from different backgrounds in different countries who are just like me working in the space sector. I will use everything I've learned to help the space sector grow in the UAE so I can give back to the country that gave me so much.
And of course, Lolo's story will be reflected by countless others around the world. And this is absolutely crucial across the aerospace sector. How do we attract our talent, draw it in, develop their skill sets? Because ultimately, they are the true citizens of the 21st century, and they will be the crucibles of creativity to drive our sector to even greater heights, building on the shoulders of giants of the past. And I want to finish by sharing some personal perspectives on this very exciting time we are living in my field in space exploration. President Trump has launched the Artemis program, the twin sister of Apollo, a return of humans to the moon within 5 years. And as somebody who remembers the last lunar landings in 1972 very, very vaguely, this is exciting me at a fundamental level, but it is exciting young people, the general public around the world. This is an ambitious program, but it is achievable. From the European Space Agency perspective and other space agencies, we are involved. And in 2024, with human boots back on the moon for the first time in 50 years, we are going to see a fundamental change, not only in our scientific understanding, but also our human perspectives. Because in looking back at the beautiful photography that we have from the Apollo missions 50 years ago, the photography is crystal clear, but of course the video technology back then was incredibly primitive. And so when we see, even from the final Apollo missions, 15, 16, 17, with video cameras, you know, we see the grainy footage. We don't really have an emotional connection with what those Apollo astronauts actually experienced on these transcendental voyages of exploration that they undertook. But of course, when we see images taken by Lunar Reconnaissance Orbiter, this is what the Earth looks like from lunar orbit. And in a few years, we will have humans directly seeing this and having this view and being able to share it with all of us back here on Earth. What astonishes me about this image is that we see just how special our planet is in the solar system. Because on Earth, uniquely, we have a planet that is teeming with life. And for billions of years, life has changed the fundamentals of our atmosphere, of our geology, of our surface. Life has fundamentally changed the geological history and atmospheric evolution of our planet. And this is something that we see not just from the moon, we could see from astronomical distances. If I was an alien visitor to our solar system, you know, I would ignore the majesty and the grandeur of Jupiter and Saturn, the gas giants and their retinue of dozens of satellites. And this is where I would come to. Because uniquely, this is not a place where life has tenaciously clung on. This is a place where life has fundamentally changed the evolution of the planet. It is a very special place. And it is through our achievements in space science and in aerospace that we have truly come to understand not only a new level of our relationship with the universe, but a better understanding of how very special our home planet is. And I would like to finish, therefore, with the thoughts of the Apollo 15 commander, Dave Scott. In landing in 1971 at the landing site of Hadley-Apennine, it was arguably the most beautiful of the Apollo landing sites. And these were his first words as he set foot on the surface of the moon. As I stand here today, I'm reminded of a fundamental truth. Humanity must explore, and this is exploration at its greatest. Now, for many years, I thought he was talking about space exploration, but I now believe he was talking about the voyage of exploration that the human race has done for more than 200,000 years, since we first emerged as a species. And that's only been possible in building our civilizations, in building our cultures, in building our technologies, by harnessing the power of science, mathematics, engineering, medicine, language, communications, history. In other words, it is about learning. And if we are to continue on this trajectory of future development, it is absolutely crucial that we inspire, support, and drive forward our next generation with the right skill sets to be able to do this, not just for economic benefit, but for the benefit of us as a culture globally. Ladies and gentlemen, shukran, thank you.